Welcome everyone for this innovation talk presented by Food and Biocluster Denmark. Food and Biocluster Denmark is the new supercluster maximizing innovation for the food and bioresource industry in Denmark. My name is Helle Friis and I will be your host today. And today we are focusing on supporting a sustainable food production and value chain with air gases. And to share valuable insights from this industry, I have invited Elodie, food and pharma specialist from Liquid, at today's digital studio due to the current situation. And Air Liquide is one of the largest gas and gas solution provider in the world, with more than 67,000 employees in more than 80 countries. They support various industries, including healthcare, aerospace, water treatment, and of course also the food industry. And for those of you watching, please engage in the talk we have here by sharing your thoughts, comments, or questions in the chat function. You're welcome to use the mutual chat function or the private one, and then I will do my best to bring them into the conversation. So Elodie, can you shortly introduce yourself and share the story of Air Liquide?
Yes, of course. Thanks for this introduction, Helle. Hoping everybody can hear me nicely. So my name is Elodie, and I'm working as a food and pharma specialist for the Nordics, and I'm based in Malmö, Sweden. So this is one of the reasons why I cannot be with you, Helle, because it's a little bit complicated to cross the border at the moment. And yes, you gave a very nice introduction about Air Liquide, and I often get comments about the name Air Liquide, liquid air. Sounds a little bit interesting, right? And the reason for this is that you can actually liquefy air. And one of the founders of our company was actually one of the pioneers that for the first time was setting up a process to liquefy the air in order to separate the different components of the air. So this is the reason why. And as you mentioned, we are quite many people in that company. We are about 67,000 co-workers, and we work for the healthcare segment, but also industry. And when it comes to health, if I should give some examples, maybe I will pick some examples related to the current context. So it talks to people like medical oxygen. Is something that we supply. We also collaborate in building respirators, for instance, or cold chain solutions to deliver medicines such as vaccines. So many of these aspects talk to people in the current context. And when it comes to industry, I cannot give you a list of all the industry we serve just because there is gas everywhere. And that's the magic thing with gas. It's omnipresent, but you don't necessarily think about it. But some examples, you have the energy segment, metal industry, food and pharma, that's my big focus, automotive, and so on and so forth. I used to say that at Air Liquide, we do everything from creating the bubbles in the beer to powering space shuttles. So this is how broad we work at Air Liquide.
And Elodie, now that we are talking about air can be a bit of a fluffy word to work around, and it can seem obvious and also very complicated. Can you elaborate a bit on what you mean with air?
Yeah, exactly, because you are breathing all the time and you don't necessarily think about the science behind it. And when I tell people that I work with air, it's often taken with a surprise, like, you work with air? How hard can it be? Like, okay. So actually, to give you some insights about what happens, what is air? Air is about 78% of nitrogen. If you go back to your chemistry classes and so on, nitrogen is this N2 molecule, and it doesn't do so much. It's what we call the inert gas. It's here. It's not toxic. It's not necessary for life. It's just filling up the atmosphere. But it has some very nice, interesting characteristics that we use for the food business, and I will talk about that later. And then you have about close to 21% oxygen. You might be more familiar with the oxygen because it's necessary for human life. And oxygen has also some super cool characteristics, and I will also talk about that. And the rest, 1%, is a mix of different small molecules. You have argon, then you have a bit of CO2, carbon monoxide, methane, and so on and so forth. Okay, So what we do at Air Liquide is that we take the air and then we purify it, we compress it, and we distillate it. It's a long story, very short. And in the end, we are able to separate the three main molecules. Nitrogen, argon, and oxygen those three are super interesting in the food business. But there is one more molecule that will come regularly into this food innovation talk, and I need to explain where it comes from. It's the carbon dioxide. You may know it, it's this CO2 molecule. And you may know it because it has quite some reputation. It's a greenhouse gas, and therefore it's not an option for us to produce CO2 to sell it. But CO2 is actually a waste that we can transform into a resource, because CO2 can actually save life. It's with CO2, when you compress it, that you make the ice to transport the COVID vaccine, for instance. And with CO2, you can also sustain your environment and help neutralize the pH of the water before to send it into the river so that the fish don't die. And you can also use it to deliver safe food to people using it in the cold chain. So CO2 is a super interesting molecule, but we shouldn't produce it. So what we do at Air Liquide is that we go to industry that produce CO2 as a waste, and then we capture it and we purify it, and then we put it in a bottle. So for instance, in Sweden, one of our CO2 supplier is an industry making alcohol, because you make fermentation and then you produce CO2 that goes into the atmosphere on alcohol. So instead of just releasing it, we capture this waste and we try to give it a function. So just to give you some context, and then when you have these different molecules, you can put them in bottles, or if you have a big consumption, we will go with a truck and we will fill a big tank that we can install at our different customers. So this is for the air, and as you understand, air is our core business at Air Liquide. But also in air, you have all these small molecules with superpowers, and I will talk about these powers in a second. But I wanted to take a little bit of a step back to start this innovation talk and talk about the 17 United Nations goals, because they are a centerpiece in Air Liquide in the way we want to improve our daily work. And for that, we have many different initiatives in place. For instance, developing new energy with hydrogen, or offsetting carbon footprint using green energies, and you trying to solve major environmental issues and curing sick people, developing microeconomies, and so on. So there is a lot going on, but because the fit is 30 minutes, I won't have time to explain everything here. So there is 4 goals that you need to keep in the background, and it will be giving the tone of this fit. It's the hunger goal, the good health and well-being, responsible consumption, and climate action. And what these goals have in common, it's, for instance, food waste and food losses. And it's something I was not necessarily aware of when I started working at Air Liquide, but one day I got this presentation and that struck me. You don't really realize how much CO2 is emitted due to food waste and food losses every year. And if food waste and loss was to be a country, it would be the 3rd country in terms of CO2 emission after China and USA. And this is huge, and you don't necessarily realize that. And it's very obvious for people, like for me, to realize that there are emissions when I take an airplane, but I don't necessarily have the tools to compare it when I throw a liter of milk in the sink because I didn't use it on time. And these CO2 emissions are such dramatic issues. And of course, we need to do something to limit this problem. If you look at different industry segments, you can realize that the dairy industry and the meat industry are large emitters. A lot of this kind of food doesn't reach the consumer table. But one of the biggest drama happened actually with the fresh food like fruit and vegetables. And here it's close to half of it that actually never reach the end consumer's table, or if it reaches it, that end up in the trash bin anyway because it's wasted or you don't have a use of it, or so on and so forth. So those are some numbers that maybe can be for you like it was for me when I first realized it, eye-openers, and we have that in mind when we work in our business.
And how do you at Air Liquide then see solutions to these clear challenges there is?
Good question. So this is going to be the heart of this presentation. There are different ways to see it. There are different possibilities and different ways to work. If you realize by 2050, we will be close to 10 billion on Earth. This is a lot of people to feed. So we need to produce much more food if we want to keep up. But as you saw just before, it's not just about producing the food, because a lot of this food doesn't even reach the consumer's table. So we need to make sure that we actually use it the best possible way and stop wasting as much. One solution to be able to do that could be to extend the shelf life of a food product, okay? There are different ways to do that. You can use chemical preservative, but of course, when you manufacture chemicals, it also comes at a cost. It also is energy consuming and so on. It's not something we work on at Air Liquide, but there is another way to do that. It's to use what we call MAP, modified atmosphere packaging. And that's actually playing with the air molecule in the package in a very natural way, without adding any chemical or any transformed compound. And the map will be today one of my points of focus. So I will explain you in more detail what we mean by map. But of course, it's about 41 tons of food that we throw every second in the world. And that is so much. So map is one solution to extend the shelf life, but then to preserve the food on an even longer period of time, frozen can also be an option. And by frozen at Air Liquide, we have very strong expertise in what we call cryogenic techniques. You might not all be familiar with cryogenic techniques, and that's normal. So I will touch base on that a little bit later on and explain you the principle and how does that work. So don't worry about that funny word. And lately, most of the consumers, if you ask opinion, they want to consume fresher and more natural. So this is why MAP and frozen are two very important things to talk about, and that I wanted to present those options to you today. But we should never forget that in the way we work in general, we need to make sure that we minimize our carbon footprint in what we do and what we install and what we sell to the customers. And at Air Liquide, we are the pioneers in that domain because now we have created a carbon offset program for our gases, our food gases. And this is called the Green Origin gases. And I will be very happy to present that program to you because it's a new development at us and we are very proud of it. The incentive came from our client. So I will keep it for the end because I like to keep the best part for the end.
It sounds very interesting, and it's clear that there are multiple solutions and maybe not that one solution fits for everyone. And that's of course very important to be aware of, especially in the food industry. But can you tell some more about that? How is it in practice that you can use air to extend shelf life of food products?
Yeah, it sounds a little bit strange when you just listen to it because, yeah, how does that work? Well, the principle is actually quite simple. Modified atmosphere packaging. I just need to clarify first. I got regularly the feedback like modified. Does it mean it's like some kind of GMO or something? No, it's not. It's just the air molecule. You package the food in a package, in a pouch, but instead of having air, you will keep the same air molecule, but you will change the proportions. And by doing that in the right way, when you have expertise about the food composition, you can actually achieve great results in order to extend the shelf life. If I should give some examples, we can, for instance, prevent oxidation. Oxidation is mostly due, as the name calls for it, due to the presence of oxygen, which is an oxidant. And that can give off flavors. For instance, it will taste rancid. It can modify the color of a food product. For instance, the orange juice will turn brown because the pigment will react with the oxygen. So there are a lot of different phenomena that impact the food due to the presence of that oxidant in our environment. But if you remove the oxygen from the package, then there is no more oxidation problem. So that's one way to do it. You can reduce the microbial activity. And one way to do that is use CO2. CO2 has a bacteriostatic effect. What does it mean? It will lower the growth of microbes in the package. So that's a great thing to use, really. In general, you can preserve the organoleptic properties of a product. That means the color, the smell, the pigments, and so on. And due to that, you can extend the shelf life of a product. And thanks to that extension, the customers now can have a better transport towards the reseller, because you have more time to transport your package to your selling place and in the end to your customer. But also you have less product return, because the packages of food are more stable on the shelf for a longer period of time. And finally, don't forget that now you can reduce, or even in some cases you don't need chemical preservative anymore. Just by changing the proportion of the air molecule, this can be enough for you to actually manage to have the shelf life times 2, 3, 4, depending on the product. So that's a really, really interesting process to implement. And I wanted to maybe show you some examples so you can have a little bit of a feel for it, maybe. So I picked 3 different kind of product to give you a little bit of a big picture. I don't have the time to make a catalog today. But if I take the salad, for instance, the salad breathes. And many of you, I don't see your faces down there, but you might be laughing like, the salad is breathing. What does she mean? Well, yes, it takes in oxygen, and then there is some oxidation process for the sugars, and then it will release CO2 and water. And what we want is, if you let the salad on the table, it will keep on breathing, so it will mature and eventually die in a certain period of time. Now, if we want to extend the shelf life, we need it to keep breathing, but slower, so that it will actually mature over a longer period of time. And to do that, we need oxygen, but we just put a lower concentration of oxygen. If you remember at the beginning, I explained you it's about 21 in the air. Let's put just 5. And then all of a sudden, you can have the salad fresh for a longer period of time. On the slide, you might see written a little bit all over the place, Aligal. Aligal is the air liquid food grade gas. So, you know, it's just a brand name for the food grade gases. For pizza, for instance, pizza is quite moist. It's full of carbs, so it's perfect for bacteria and mold. So what we can do is put 30% CO2 in the package. The CO2 will have a bacteriostatic effect, and we can have a lower growth, microbial growth in the pizza package. And finally, nuts. I picked this one because it's a bit different. It's a very dry product. And because it's dry, it's very concentrated in fats. And fat will react easily with oxygen. So it will taste funny pretty quick. And we cannot put too much CO2 in there because CO2 can dissolve in the fat. So what do? We just put nitrogen. Instead of 78% like you have right now, we put 100. Nitrogen doesn't do anything, it's inert. And then we can save the nuts for a very, very long period of time, like several months, without any change of characteristic with the taste and so on. So yes, I hope this gave you a little bit of an understanding how the MAP process is actually working.
I think that was some great examples, Elodie, and I have received a question here from one of the participants. And if there's others of you out there with questions, just please use the chat function and I'll bring them into the conversation. And the question goes on, is there any specific food categories or sizes of businesses that this is especially useful for, that should stay away from it? Just to be very clear, can it be used for all food products and all sizes and types of companies, these solutions?
Yeah, that's a great question, actually. Thanks for raising this one. And I actually can use the next slide to give you an overview. So if you talk about food companies, which kind of food product we can target. It's a very large portfolio of food that actually can suit MAP. So at Air Liquide, we have about 15 or more than 15,000 customers in the world. So we have packaged a lot of different sorts of food. So fish and meat and pasta, bakery, dry, dairies, even medicine in the end is also some kind of MAP. It's not air in the little pouches. It's usually a pharma grade gas. But in terms of what food you can package, it's a very, very large variety of product. We have a lot of experience on great databases, so don't hesitate to come back to me afterwards if you want to know if we have some return on experience on a particular product. And if we don't, it's super easy for us to make tests. We can come to you at your production facility with a gas bottle and just try it. Or you can come to us. We have a test center in the south of Sweden. So you are so very welcome to join us for a test session. But then you were also asking about the size of a company. There is no real size. MAP is a process that's available for everyone. If you are a small local producer, or if you are a startup company, well, you can buy a small packaging machine that fits on a table, and then we can come with a bottle and connect it, and that's it. You are independent, and you can start your packaging process. If you are bigger, we put several bottles, and if you are even larger, large-scale producers, we put a tank. So it's just as simple as that, and as versatile. So there is actually, no limitation in terms of size of client. Everybody can use MAP.
That sounds very interesting. We've actually also received another question, if it's okay, Elodie. It goes on this: if you use this method, or if you remove oxygen or lower the level of oxygen to reduce oxidation, can that then lead to an anaerobic environment and therefore result in faster spoilage of the food product?
Yes, that can be correct, indeed. If you completely remove the oxygen from the package, you get into some anaerobic conditions, which is a word we use when there is no oxygen available. But you also need to know that for the packaging machine, they are not 100% performant. So you can manage to get the oxygen level lower than 3%, 2%, 1, 0.5 even. If you have very efficient packaging machine, it's very hard to have it exactly 0. For certain type of product, which shouldn't be in complete anaerobic condition, and for instance, I will talk about white fish. In the white fish, you can have the development on some bacteria called Clostridium botulinum. And those bacteria grow in anaerobic condition when there is no oxygen, and they are very toxic for us as human beings. We can even die from that. So we don't go from anaerobic condition. So we always keep a remaining concentration of oxygen in the package, or we add actually a little bit to make sure that we avoid those kind of conditions. So yes, if you have a specific case, we will help you with our expertise to identify together with you what is the best ratio to use. But that was a very relevant question indeed.
Thank you.
And yes, still in this context, I just wanted to explain that at Air Liquide, as I just said, we will help you identifying what is the best gas mix that you will need. And we will supply you with a gas and the regulator, the tank if you need, and so on. But on the side of that, you will also need to identify what kind of package you want to use, as well as buy a packaging machine. And just wanted to mention, it's still very important to respect the very high hygiene standard in the production chain, as well as the cold chain parameters, because MAP will not help to kill bacteria. If the product is already wasted from the start, it will stay wasted. So it's still important to work in very safe and hygienic conditions.
Do you see other methods that can achieve the same outcome or a similar outcome?
Yeah, I mean, similar outcome. When it comes to fresh product, I would say that MAP is a very interesting solution to consider, and it's super easy to make tests. We have a lot of experience with that, so I would recommend to get in touch with us. We can have a chat, and it's a super interesting topic to work with for sure. Then if you talk about longer preservation period, and you can also consider freezing. We talked a little bit about that at the beginning. At Air Liquide, we have strong expertise with cryogenic freezing. It's a funny word, don't be afraid. It means that we will freeze very quickly using, for instance, liquid nitrogen or carbon dioxide under the form of dry ice. Liquid nitrogen has a temperature of minus 196 degrees. So it's really, really cold. And the dry ice, carbonic ice, is about minus 80 degrees. So as you understand, we are really using extremely cool temperatures to freeze. And the consequence of that is that it's super quick. So you will be now able to lock, for instance, the flavors, the volatile compounds, the moisture that has the tendency to exit the product pretty quick. You can now lock it in very, very quick. You will be able to preserve the texture of the food because you will not have big water crystal growing. They don't have time to grow. So they will stay really small. So the texture feels very, very nice, like on the initial product. And then on a logistic perspective, in your food production chain, it's a game changer compared to mechanical freezing, really. If you were used to freeze something and it took hours, in some cases, it can be done to minutes. So it gives you much more flexibility, much more versatility, and you don't have all this waiting time anymore. So cryogenics is a really interesting science. And if I should give you some visuals so you understand what we're actually talking about, it's still a little bit blurry. Here are two examples typically of what kind of machine we use. You can see a batch freezer, a cabinet. It's like your fridge, but in bigger and much more efficient. So this is an example. So you can actually put the trays inside and close, and it will be frozen pretty quick. If you want to work online, you can also go for what we call a tunnel, a cryogenic tunnel, as you can see here as well. So the product enters fresh or warm or certain temperature and leaves frozen. So here are some examples, and if you are more curious about it, come and visit us in Sweden.
It sounds like a great invitation, and I'm sure as soon as borders are open, some companies are eager to come visit you. But today we're also talking about sustainability, and can you share on how the carbon footprint is minimized with some of these air solutions?
Yeah, indeed. And as you may have understood now, MAP on cryogenic freezing, are two ways to limit food waste and work into a more sustainable food chain in general. But as I explained at the beginning, at Air Liquide, we strive to actually develop processes and minimize our carbon footprint. And I should say that in the Nordics, many of our clients are role models when it comes to the green philosophy and reducing the footprint of every single step of a production chain until the delivery. It's a very, very high standard, and the client gave us the incentive and the motivation kick to get better. And this is what we did, and we have worked very hard on that to be able to deliver a product that matched their expectations. So I should give credit to our client that actually pushed us at getting better. And today we are the pioneers in the Nordic to be able to provide to clients climate smart liquid gas in bulk form. And this is so great. And what does it mean? It means that 100% of the energy which is required for producing and storing the gas, you saw the distillation process and so on, well, we will actually purchase 100% of that as wind and hydropower energy. So we'll be purchasing green energy to compensate for that at 100% rate. And this is available for oxygen, nitrogen, argon, carbon dioxide at food grade. So all the key food gases. But as you remember, we also need a truck to come and fill the tank. So the truck will drive on the road, and we will also have CO2 emissions here. So we will track the kilometers, and then we will offset those kilometers, those emissions, but not using any kind of program. We are using the Gold Standard Foundation program. You can see more on that on the internet. It's a very high standard program which make us feel very secure in terms of what we actually compensate. So this is behind our green origin offer in order to have you use climate smart gas in your company for packaging and freezing your food. And this is our commitment for you to help transiting to a more climate smart production chain. And I just want you to know we stand absolutely against greenwashing. So we want our offer to be super transparent, and we have a third-party auditor that audits us every year to make sure we talk the talk and we walk the walk. So all our Bell customers can also get a validation statement to tell them exactly how much CO2 emission they have saved thanks to buying green origin gas from us. So we want it to be as transparent as possible, of course. And I would end here by giving you a small teaser, and I'm super excited about this. It's that by May, now like in less than 2 months, we will be able to have for our customers also cylinders, so gas bottles, filled with climate smart gas. Now we had it just on bulk, but now we will soon have it available for bottles as well. And our clients have been waiting for that. So we have pushed it really, really hard now to have it available. And I'm super proud to tell you that this is soon available in the Nordic regions.
That sounds very relevant and very interesting, Elodie. Thank you. We just have a final question here from one of the participants who's asking, what is the reason that you have to declare on food products that you use MAP?
Yeah, it depends on the country. In some country, yes. In some country, no. So I will have to check for what region it is or what country it is. But depending in the country, you might have to write on the package under modified atmosphere. But there is no in under or such thing because there is no chemical additive addition inside. You are mute, Hele. I think you are talking.
I see it's a Danish company, so it must be related to the Danish food legislation and the authorities behind that. All
okay,
right.
I will have to double check because I'm in Sweden right now, so I don't want to confuse. But I can definitely send an email so I don't say something wrong.
Indeed. Thank you so much, Elodie. Thank you so much for sharing your insights and expertise on this area. And if any of you watching out there still have a question, feel free to contact Elodie directly. And I can also help make introductions between you. So thank you, Elodie, and thank you all for watching. And if you would like to stay updated on news and activities from Food and Biocluster Denmark, you can sign up to our newsletter on our website. So once again, thank you all for watching and have a nice day.